Hello everyone. Hope you all are taking good care of yourself. Okay, myself Vinayak Jaiswal is going to start a chapter 4 playing with the numbers of your book New Learning Mathematics of class 6. So children, in this chapter we are going to discuss factors and multiples of a number, common factors and common multiples, types of natural number, even and odd numbers, prime and composite numbers, twin primes, co-prime and perfect numbers, divisibility test of natural numbers, general properties of divisibility, prime factorization of natural numbers, HCF and LCM of natural numbers, and properties of HCF and LCM of natural numbers. So children, let's start the topic. So children, look on the screen children, one picture I am showing you. John's uncle gave him 24 muffins to distribute among his friends. This means John has 24 divided by 1 is equal to 24 muffins. Now he wants to distribute equally among 6 children. How will he do that? 24 divided by 6 is equal to 4. That is 24 is equal to 6 into 4. So he will give 4 to each. Now what if 2 more children come to his place? How will he distribute the same number of muffins among 8 children? So he will give 3 each, that is 24 divided by 8 is equal to 3, or 24 is equal to 8 into 3. Suppose 4 more children visit his place at the same time. Can he distribute 24 muffins equally among all children? Yes, he can. He will give 2 each, that is 24 divided by 12 is equal to 2, that is 24 is equal to 12 into 2. So children, from this calculation, what do we see? We can see that 24 can be written as a product of two numbers in different ways, as 24 is equal to 6 into 4, 24 is equal to 8 into 3, 24 is equal to 12 into 2. This means 2, 3, 4, 6, 8 and 12 are exact divisor of 24. So children, these are factors of 24. So children, if anybody asks you what do you mean by factors, then what will you say? A factor of a number is defined as a number which is an exact divisor of that number. Suppose we want number 12. Think about the numbers you can multiply together to get 12. That is 3 into 4 is equal to 12, 2 into 6 is equal to 12, 1 to 12 is equal to 12, which shows that 1, 2, 3, 4, 6 and 12 are factors of 12. Now children, facts about factors. First, the number 1 and the number itself are always factors of that number. Next, every factor is less than or equal to the given number. Next, every factor of a number divides the given number completely or exactly, that is without remainder. And last, the number of factors of a given number are finite, that is it is uncountable. Now next topic, common factors. When two or more numbers have the same factor, that factor is known as a common factor. Like for suppose, let us find out the common factors of 6 and 18. So children, 6 is equal to 1 to 6 and 6 is equal to 2 into 3. Therefore, factors of 6 is equal to 1, 2, 3, 6. Similarly, find the factors of 18, that is 1, 2, 3, 6, 9 and 18. So children, the numbers which appear in both the list are 1, 2, 3 and 6. So therefore, children, common factors of 6 and 18 are 1, 2, 3 and 6. Like question, write all the factors of the following number. Suppose 23 and next one is 36. So 23 is equal to 1 and 23. Therefore, factors are only 2. And next, factors of 36 is equal to, just see, look on the screen, that is equal to 1, 2, 3, 4, 6, 9, 12, 18 and 36. Very simple children. If you adopt the method, you will know how to find the factors of any number. Now let us understand the meaning of perfect number. A perfect number is defined as a number for which sum of all its factors is equal to twice the number. Like for example, the factors of 6 were 1, 2, 3 and 6. Now sum of all the factors, that is 1 plus 2 plus 3 plus 6 is equal to 12, and which can be written as 2 into 6, that is twice the number. Therefore, children, 6 is a perfect number. Likewise, 496, find the factors of the given number. that is 1, 2, 4, 8, 16, 31, 62, 124, 248 and 496. Therefore, children, add all the factors and we will get 992, which is the sum of the factors. And after that, if you are able to write, that is twice the number, that is 2 into 496. So, we can say the given number is also a perfect number. So, children, now come to the next topic, that is our multiples. Now, children, 6 eggs are present in one container. Look on the screen. Now, if 4 such containers are present before you, how many eggs must be there in 4 such containers? There will be total 6 into 4, that is 24 eggs. And if there are 7 containers, then the number of eggs in 7 containers will be more, that is equal to 28, that is 7 4s are 28. So, children, to find the total number of eggs, here we have multiplied the number of eggs in one container by the number of container, and this is the concept of multiple. So, children, if anybody asks you what is multiple, you have to say a multiple of a number is defined as a number which is a product of that number and any other whole number. For example, multiples of 3 are 3, 6, 9, 12, 15, 18 and so on. Now, children, facts about multiples. First, every multiple of a number is greater than or equal to that number. Next, the number of multiples of a given number is infinite, it cannot countable, uncountable. Every number is a multiple of itself. Now, children, what is the meaning of common multiple? Common multiples of 2 or more numbers are the multiples that are common to every given number. Like suppose, find out the common multiples 4 and 6. So, first write the tables of 4 and 6 separately, look on the screen, and next write the table of 4 separately. And children, what do you see? First 10 multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36 and 40. And first 10 multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54 and 60. So, the common numbers which appear in both the list are 12, 24 and 36. So, these are the common multiples. Like for suppose one question, find all the multiples of 9 up to 100. So, multiples of 9 is equal to 9, 18, 27, 36, 45, 54, 63, 72, 81, 90 and 99. So, very simple. Now, let us try to understand, children, next one, the topic prime and composite number. So, what is the meaning of prime number, children? Prime numbers means the numbers other than 1 whose only factors are 1 and the number itself are called prime number. That is, numbers having only 2 factors, that is 1 and the number itself. Like for example, 5 and 23 are prime numbers because they have only 2 factors, 1 and the number itself. Next, composite number. A composite number is defined as a number having more than 2 factors, like 9 and 14 are composite number. And children, if you see carefully, the factors are more than 2 of the given numbers 9 and 14. Now, children, note 1 is neither prime nor composite number, and any whole number greater than 1 is either a prime or a composite number. Now, one question, write 7 consecutive composite number less than 100 so that there is no prime number between them. And answers is 89 and 97 are the prime numbers. 90, 91, 92, 93, 94, 95, 96 lies in between 89 and 97. So, children, all the numbers have more than 2 factors. Therefore, we can say these numbers are composite numbers. Okay. Now, next topic, children. Now, we will learn Eratosthenes' sieve to find prime numbers. Now, he was a Greek mathematician, astronomer and also a geographer in Egypt in 200 BC. He invented a method for finding prime numbers that is, children, still used today. Now, look on the screen, write all the numbers from 1 to 100. Suppose you have to find out the prime numbers between 1 to 100. So, first write all the numbers from 1 to 100 and step 1, cross out 1 because it is neither prime nor composite number. Next step, encircle 2. All the numbers divisible by 2 are even numbers, children. So, cross out all the multiples of 2. Next step 3, encircle 3 and cross out all multiples of 3. Similarly, children, step 4, encircle 5 and cross out all multiples of 5, and continue in this manner, children. And afterward, last, you will see all the encircled numbers are prime numbers, and rest all the crossed out number except one are composite number. So, children, between 1 to 100, the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Next topic, children, co-prime numbers. Any set of numbers which do not have any other common factor except one are called co-prime or relatively prime numbers. Like for example, factors of 5 are 1 and 5, factors of 6 are 1, 2, 3 and 6. So children, what this shows? It shows that 5 and 6 have no common factor except 1. Therefore, we can say these are co-prime number. Now some properties of co-prime number. First, all prime numbers are co-prime to each other. Next, any consecutive whole numbers are always co-primed. After that, sum of any two co-prime numbers is always co-prime. And last, co-prime numbers need not to be co-prime numbers. Now children, next topic of discussion, that is twin primes. What do you mean by this? Twin primes are a pair of prime numbers which differ by 2. First few twin primes are, that is 3 and 5, next pair 5 and 7, next pair 11 and 13, then next 17 and 19, after that 29 and 31, and last 41 and 43. These are the few twin primes. Now children, express one question I am giving you. Just see on the screen, express 44 as a sum of two odd primes. So children, here you have to find out two numbers which are odd as well as prime number and whose sum is also 44. So first write odd prime numbers up to 44. Which are those? 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41 and 43. Now let's find out a pair of number whose sum is 44. So sum of 3 and 41 is 44. So children, we can write 44 is equal to 3 plus 41. Very simple, children. Now next question, give three pairs of prime number whose difference is 2. So the answer will be 5 and 7. Then next 11 and 13 and last 41 and 43. Next topic of discussion, children, let us try to understand some test for divisibility of numbers. First one is divisibility by 2. If the number ends with 2, 4, 6, 8 or 0, so children, it is divisible by 2. Like for example, 28, 54 and 96 are divisible by 2. Why? Because all the numbers ends with 8, 4 and 6 respectively, if you see the given numbers. Next children, divisibility by 3. If the sum of the digits of any number is divisible by 3, then that number is divisible by 3. Like for example, 429, add all the digits of the given number, which is 15, and it is divisible by 3. So children, we can say 429 is divisible by 3. Next children, divisibility by 4. If the last two digits of any number and the number formed by last two digits is divisible by 4, then that number is also divisible by 4. Like for suppose 628, the last two digits are 2 and 8, and the number formed by last two digits is 28, which is divisible by 4. So children, 628 is also divisible by 4. Next children, divisibility by 5. If the digit in the ones place of a given number is 5 or 0, then children, it is divisible by 5. Like suppose 95, if you see, ends in 5, so it is divisible by 5. 680 ends in 0, therefore it is also divisible by 5. Next children, divisibility by 6. If a number is divisible by 2 and 3 both, then that number is also divisible by 6. Like for example, 246, if you see, this given number is divisible by 2 and 3 both. So children, we can say 246 is also divisible by 6. Next children, divisibility by 8. A number is divisible by 8 if the number formed by its last three digits is divisible by 8. Like for example, 2544, and last three digits are 544, and the number formed by last three digits is 544, and it is divisible by 8. Look on the screen. Therefore children, the given number 2544 is also divisible by 8. Next children, divisibility by 9. Same rule like for 3, a number is divisible by 9 if the sum of its digits is divisible by 9. Like for suppose example 42,471. Now add all the digits, you will see 18 and 18 is divisible by 9. So children, we can say the given number 42,471 is divisible by 9. Next rule children, divisibility by 10. Our number is divisible by 10 if it ends with a 0. Example 1570, if you see the last digit is 0. So children, the given number is divisible by 10. After that, divisibility by 11. Now children, this is a very good test to check the number whether it is divisible by 11 or not. How will you check? A number is divisible by 11 if the difference of the sum of all the alternate digits is 0 or a multiple of 11. Again I am repeating, a number is divisible by 11 if the difference of the sums of the alternate digits is 0 or a multiple of 11. Like for suppose 9,724. Now sum of alternate digit 9 plus 2 is equal to 11. Next sum of alternate digits 7 plus 4 is equal to 11. Start from the left hand corner, left hand side of the given number and find the difference between the two sums, that is 0. So children, we can say the given number is divisible by 11. Let us take one more example, 45,958. Now find the sum of alternate digit, 4 plus 9 plus 8 equal 21 and next 5 plus 5 equal 10. Therefore, 21 minus 10 is equal to 11 and this difference is a multiple of 11. So, children, we can say 45,958 is divisible by 11. Now, children, one question is showing on the screen. Using divisibility test, determine whether the given number 1258 is divisible by 6 or not. So, children, if you see carefully, the given number is not divisible by both 2 and 3. So, children, we say that the given number is not divisible by 6. Now, children, next topic of discussion, some more divisibility rules, very important children. First, if a number is divisible by any other number, then children, the given number is also divisible by each of the factors of that number. Like for suppose 18 and 72. Now 72 is divisible by 18, that is 4, which shows that 72 is divisible by 18. Now find the factors of 18. 1, 2, 3, 6, 9 and 18. Or if you want to see all the factors of 18 will divide 72 exactly. So children, we can say 72 is divisible by each of the factors of 18. Next children, if a number is divisible by two coprime number, then it is also divisible by their product. Like for suppose, let's say 90 is divisible by 5 and 9. As we know children, 5 and 9 are coprime numbers. So 90 must be divisible by their products, that is 5 into 9 is equal to 45. So 90 divided by 45 is equal to 2. Therefore children, we can say 90 is divisible by product of the coprimes, that is 5 and 9. Next rule children, if two given numbers are divisible by a number, then their sum is also divisible by that number. Like for example 21 and 18 are divisible by 3, and now find the sum of the given numbers 21 and 18, that is 39, and 39 is also divisible by 3. After that, next rule, if two given numbers are divisible by a number, then the difference is also divisible by that number. Like for suppose 50 and 58 and 54, and if you find the difference of these two numbers, that is 4, and 4 is divisible by 2. So children, we can say the given number, that is difference of given number 54 and 58 are also divisible by 2. Question, a number is divisible by both 5 and 12. By which other number will that number be always divisible? Yes children, the number is divisible by 5 and 12. So we can say 5 and 12 are coprime numbers. So the number must be divisible by their product, that is 5 into 12 is equal to 60. So the given number is always divisible by 60. Next children, HCF, highest common factor. What is the meaning children? It is the highest of their common factor. It is also known as greatest common divisor. Now children, to find the HCF of two or more numbers, we can use any one of the following method: common factor method, prime factorization method, and then one more method is there to find the HCF by division method, which I will explain at the last of the video. Now first we shall discuss common factor method. Let's find the HCF of 18, 24 and 42. So children, find the factors of all the three numbers separately, and after that find the common factors of all the three, which are, if you see carefully, 1, 2, 3 and 6. And after that children, the highest among the common factors is only 6. So children, required HCF is also 6 of the given three numbers 18, 24 and 42. Next method children, prime factorization method. Let's find the HCF of 27 and 45. So children, first we shall find the prime factorization of 45 and 27 separately. So children, look on the screen. If you see, this method is called prime division method to find the prime factorization of the given number. Now children, look on the screen. Therefore, children, 27 as a product of prime factors is written as 27 is equal to 3 into 3 into 3. Likewise, prime factorization of 45, look on the screen children. If you will find, you will get as 45 is equal to 5 into 3 into 3 into 3. Now children, multiply all the factors which appear in both the list. What do you see? 3 and 3, 2, 3 are both the list. So children, multiply both of them, and that is equal to 9, which is required HCF of 27 and 45. Look on the screen properly. Now one question, find the HCF of following numbers 18, 54 and 81. So children, find the prime factorization of the given three numbers separately, and after that children, look on the screen. 18 is equal to 2 into 3 into 3, 54 is equal to 2 into 3 into 3 into 3, 81 is equal to 3 into 3 into 3 into 3. Now multiply all the factors which appear in all the three lists, that is 3 into 3 is equal to 9. So children, HCF of 18, 54 and 81 is 9. Now children, word problem. A fruit seller has 24 apples, 40 papaya and 56 strawberries, which he must use to create fruit basket. What is the largest number of fruit baskets C can make without having any fruit left over? So children, see what we have to do, just to find the largest number of fruit basket. So we have to find the HCF of the given numbers, that is 24, 40 and 56. And after that we will see the HCF is 8. So children, a fruit seller can make 8 fruit basket, and each basket will have 3 apples. Children, okay, look on the screen, because if you see carefully, 24 divided by 8 equal to 3, then 5 papaya, since 40 divided by 8 equal to 5, and 7 strawberry, that is 56 divided by 8 equal to 7. Now children, come to next topic of discussion, that is children, least common multiple, or you can say LCM. So children, LCM of two or more given number is the lowest of their common multiple. If two numbers are co-prime, then LCM is the product of the two numbers. Remember children, if the two numbers are co-prime, then the LCM will be just the product of the two numbers. Like, find the LCM of 7 and 13. So children, multiply both of them, that is equal to 91, and 91 is the LCM of 7 and 13 because they are co-prime. Now children, next method is common multiple method. So children, very simple method. First find the multiples of the given numbers separately. Like here example, find the least common multiple of the numbers 8, 12 and 18. So find the multiples of 8, 12 and 18 separately. Very simple children. Next step, find the common multiples of 8, 12 and 72, or if you see carefully on the screen, that is 72. Okay children. And next, after that, just find the lowest among all the common multiples. Like here in example, this question, if you see, LCM is 72, and this method children works only when there are very small numbers. Okay. Now next method children, prime factorization method. Like example, find the LCM of 90, 100 and 150. So children, first find out the prime factorization of the given numbers separately. Like here, 90 is equal to 2 into 3 into 5. Then 100 is equal to 2 into 2 into 5 into 5. And 150 is equal to 2 into 3 into 5 into 5. And after that, just find which numbers comes maximum number of times. So children, multiply all of them. Like 2, maximum number 2 times, 3 also 2 times, and 5 also 2 times. So multiply all of them, that is 2 into 2, then 3 into 3, then 5 into 5, and you will get answer as 900, which is the LCM of the required numbers. Now children, common division method or prime factorization method is also a very good method, a convenient method to find the LCM of any given numbers. Now children, in this method, prime numbers In this method of prime factorization, we proceed as follows. What are those children? Arrange all the given numbers in a row. Try to understand and separate it by a comma, which is very important, children. Otherwise, you will get the wrong answer. So, children, this step, the first step is very important. Okay, arrange all the numbers in a properly line separated by a commas. Start with the least prime number which divide at least one of the given numbers exactly and write down the quotients and any undivided number in the next line. And children, repeat the process as shown below until 1 is the only common factor. And last, children, find the product of all the divisor and you will get the required LCM. Like for suppose one example is here, find LCM of the numbers 36, 48 and 72. So children, arrange all the numbers in the row, that is 36, 48 and 72 in a comma, and after that children divide by a prime numbers, that is 2, write the quotient, that is 18, 24, 36 respectively below 36, 48 and 72. Again children, divide by 2, then write the quotients, that is 9, 12 and 18 below 18, 24, 36 respectively, and repeat the process till you get at last 1. Just see on the screen. Now children, to find the LCM, you have to multiply all the divisors which in the left side, that is 2 into 2 into 2 into 2 into 3 into 3, and that is equal to 144. So children, very simple method. Suppose one question, word problem, find the least number which when divided by 18, 28, 32 and 42 leaves a remainder 5 in each case. So children, what will you do? First we should find the LCM of the given numbers, and after that children, if you see on the screen, that is equal to 2016, that is equal to LCM. Now it is the least number which when divided by the given number will leave remainder 0 in each case. So children, but we need the least number that leaves remainder 5 in each case. So what will you do? Just add that 5 to the required LCM, and you will get the required least number, that is equal to 2021. If you see carefully, 2016 plus 5, you will get the answer. One more question children, if you see, it's very common question. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again? So children, time period after which these lights change is equal to LCM of 48, 72 and 108. Now find the LCM. You will see 432. Therefore, the children, light will change together after every 432 seconds. Now convert into minutes and seconds. You will get 7 minutes and 12 seconds. So children, after 7 a.m. it will again change simultaneously, that is 7 hours, 7 minutes, 12 seconds. So children, that is answer. Now children, let us understand next topic, that is children SCF, which I discussed before, that I will explain at last. Yes children, this is the method, divisor method to find the SCF, or you can say division method to find the SCF. Now the steps to be followed are: divide the greater number by the smaller number, next divide the divisor by the remainder, then after that divide the remainder by the next remainder, and so on till then continue until no remainder is left. And the last divisor is our required HCF. Let us solve some question to understand this better. Find the HCF of 18 and 30 by this method. So children, steps here we need to find we need to divide 30 by 18. So divide the larger number by the smaller one children. And after that, what you see, the first divisor is 18 and the remainder is 12. See carefully on the screen. So we need to divide 18 by 12. That is, divide the first divisor by the first remainder. And next, now divide the second divisor 12 by the second remainder 6. That is, divide the second divisor by the second remainder. And last, what you see, the remainder comes out 0. And children, if you see carefully here, the last divisor is 6. So children, we can say this is our required HCF of the given number 18 and 30. Look more questions children. Find HCF of 75 and 180 by using division method. So children, Here we need to divide 180 by 75, and after that you will see the first divisor is 75 and the remainder is 30. So we need to divide in step 2, that is 75 by 30. What do we see? Divide the first divisor by the first remainder. Step 3, children, now divide the second divisor 30 by the second remainder 15. And what do you see? The remainder comes out 0. So children, the last divisor is 15, which is our required HCF of the given number 75 and 180. Let us have one more question to find the HCF of 3 numbers by using the same method, division method. So children, what will you do? Here children, steps to be followed are, first of all, find the HCF of any 2 given numbers, any 2, and after that, now next step, now find the HCF of the third given number that is left over and the HCF of obtained in step 1 from the first and the second number. Let us see question to understand this better. Find the HCF of 184, 230 and 276 by using division method. So children, let us find the HCF of 184 and 230. So children, what is that HCF? That is HCF is 46. Now children, find the HCF of the third number 276 and 46. So what do we see? We see the HCF comes out 46, just see encircled one because we get remainder 0. So children, hence we can say the required HCF of all the 3 numbers 184, 230 and 276 is equal to 46. Let us take one more example children. Find the HCF of 136, 170 and 255 using division method. So children, let us take any 2 number. Suppose find the HCF of 136 and 170, and we see on the screen 34 is the HCF of 136 and 170. Now children, the third number, that is 255, and HCF of the first 2 number, that is 34. To find the HCF of 34 and 255, what do we see? 17 is the HCF of 34 and 255. So children, we can say our HCF of all the 3 numbers 136, 170 and 255 is equal to 17. So what do we see children? Very simple method is here. Okay, children, in this way we can understand or better. Let us in the last question using long division method to find the HCF of 891, 1215 and 1377. So consider the first 2 number 891 and 1215. So children, find the HCF of these 2 numbers and that will be equal to 81, and after that the third number, that is 1377. So find the HCF of 81 and 1377. What will you see? Again, that is 81, remainder comes out to 0. So children, HCF of the given numbers 891, 1215 and 1377 is 81. So children, please practice this question, this type of question. So thanks for watching the video children. I hope you understood the video chapter very carefully. So keep practicing. Till then, thanks you once again. Thank you.